All right. Hello, ladies and gentlemen. Welcome to Trig Identities, Addition and Subtraction. So we're going to learn some new formulas. If you have your green sheets out, that would be helpful. We're going to add today, so to the 5 formulas we've already done. You recall those, the reciprocal, Pythagorean, all those. Today we're adding addition and subtraction formulas. So it's pretty, that looks kind of crazy, doesn't it? There's a lot going on there. And years ago, one of my professors told a story about sine and cosine, told a story about it, which helps me to remember much better. I'm going to tell you the story. It may or may not help you. You can figure out different ways to remember, but let's kind of go with it. So this is how the story goes. Sine is the really nice trig function, and cosine is not so nice. Not so nice. So I'll show you the evidence of that. So if you ask sine to add, look, sine adds. If you ask sine to subtract, sine subtracts. Very nice. Sine does what you ask them to. If you and notice also, not only if you ask sine to add, sine adds, and if you ask sine to subtract, sine subtracts, but sine also shares. Look, so see, let's make this a little bit bigger. See how sine and cosine, so the formula goes sine of the first angle times cosine of the second angle. Isn't that nice how it's sharing? He doesn't have to go first, it's fine. And then cosine, then it switches cosine of the first angle and sine of the second angle. Very nice trig function. On the other hand, cosine is not so nice. If you ask cosine to add, cosine's going to subtract. And if you ask cosine to subtract, cosine's going to add. And not that sharing. Look who has to go first. Cosine. Both of them. Cosine of the first angle and cosine of the second angle. That's not very nice, right? And then sine gets to go last, sine of both the angles. And see, it did it again. Cosine of the first angle, cosine of the second, and sine gets to go last. So given those two trig functions' personalities helps me remember. I have never forgotten the these addition and subtraction formulas. Hopefully that will help you. If not, you can come up with a different way to remember it, but that's how I remember them. Now, I don't really have a nice little, story for tangent. These addition and subtraction formulas for tangent are pretty important, but they do have some patterns that we can talk about. If you look at when tangent is adding, notice that the numerator has them, tangent s plus tangent t. It has them adding. And when tangent is subtracting, notice in the numerator it's tangent s minus tangent t. And it's always the first angle first, s first. So that's a pattern that we could remember. The other pattern would be in the denominator, it always starts with a 1, always a 1. And when tangent is adding, you have subtraction, you have the opposite in the denominator, and then the product of tangent s, tangent t. And when you're subtracting, you have addition in the denominator, and you're multiplying tangent s times tangent t. So hopefully the patterns there will help you remember those two formulas. Okay, so those are the formulas that we're going to be working with in this lesson. All right, are we okay? Questions so far? All right, so let's look at then, we have some examples to go through. So let's go to our examples. All right. So let's look at our first example. What they're asking us to do is to use an addition or subtraction formula to find the exact value of the expression. Okay. So we're in degrees. That usually is a bit easier for us. I have one of its example of each. What we're going to have to do is try to figure out, and you can use addition or subtraction, you can use any angles you want. It's not just a set thing, but we want to use unit circle angles. So for degrees, we would want to have like 45 degrees or 60 degrees or 30 degrees or 90 degrees, something like that. We would need to add or subtract those two numbers in order to get 15. That's what we're looking for. Adding or subtracting two of our unit circle values to get 15. So in this case, what I chose was 45 degrees minus 30 degrees. Again, there's a lot of choices. You don't have to do the exact same thing. So we're going to do secant of 45 degrees minus 30 degrees. Okay, we don't have a formula for secant, subtraction formula for secant, so we're going to have to turn it into its reciprocal. So that's the same thing as 1 over cosine of 45 degrees minus 30 degrees. Alright, so let's do our formula. Okay, remember cosine is the not so nice one. Remember, cosine's the not so nice one. First of all, he wants to go first. So it's cosine 45 degrees, cosine 30 degrees. We asked cosine to subtract, so what's he going to do? He's going to add. He's going to do the opposite because, you know, he's not that nice. So then now in the back, there goes sine. Sine is last. So sine 45 degrees, sine 30 degrees. So that's our formula. Okay? So that's cosine 45 degrees, cosine 30 degrees, plus sine 45 degrees, sine 30 degrees. So now we need to know our unit circle values. We need to know that. So we do. I'm sure we all do. So we know cosine at 45 degrees is root 2 over 2. Cosine at 30 degrees is root 3 over 2. Plus sine of 45 degrees is root 2 over 2. And sine of 30 degrees is 1/2. Okay, just continuing to simplify. I multiply root 3 times root 2 and I get root 6. And 2 times 2 is 4 plus root 2 over 4. So I simplify, so they have the same denominator, thankfully. So that's 1 over the square root of 6 plus the square root of 2 over 4. And then I flip and fix my complex fraction. So here's the main fraction bar right here. So I flip and fix my complex fraction and I get 4 over root 6 plus root 2. So that is the exact value. Exact means there's no decimal approximation and it's non-calc. Okay, exact means no decimals and non-calc. I think we're probably familiar with that. Alright, how are we okay on that? Okay. So let's look then at this next one. The typically the radians give us a little more trouble just because they're fractions. It kind of troubles some students. They're like, oh my gosh, 11 pi over 12. How am I going to figure out what adds up to that? What I do, I mean, you can do this however you want, but this is what I do. I will take the unit circle values, like pi over 6, and I'm just going to make it like a list. So I got pi over 6, I've got pi over 4, I've got pi over 3, I've got pi over 2, and I've got 2 pi over 3. So I'm just going to come up with some. And I'm going to put those in twelfths. Because in order for me to see how to add or subtract to get to a 12th, I need it to be in twelfths. So some of y'all can do it in your head, that's fine. I can't. I need to look at it. So pi over 6 in twelfths would be 2 pi over 12. And pi over 4 in twelfths would be 3 pi over 12. You see what we're doing? I'm just putting everything in twelfths because this is in twelfths. So 4 pi over 12, and then 6 pi over 12, and then that gives me 8 pi over 12. So I need to find some combination of adding or subtracting any of those 12ths to come up with 11 pi over 12. And you have lots of options. You don't have to all do the same thing. I mean, it's fine. If you want to do one with adding, try one with adding. If you want to try one with subtraction, try one with subtracting. We should get the same answer no matter which one you choose. I ended up choosing, what did I choose? I chose 3 pi over 12 plus 8 pi over 12. That's what I chose. Again, you don't have to choose that. You can choose something different. But I chose to do 3 pi over 12 plus 8 pi over 12 because I know that's 11 pi over 12. Now I'm going to put it in back in unit circle because that's kind of confusing. So sine of 3 pi over 12 we said was what, pi over 4 plus 8 pi over 12 was 2 pi over 3. Okay, so now I've got that kind of settled. I'm going to use my sine addition property. Remember, sine is the nice one. Sine shares. Sine does use the first angle first, though. So sine of pi over 4, and then sine shares. So it'll be cosine of 2 pi over 3. If sine is supposed to add, is sine going to add? Yes, sine is going to be adding. Now sine uses the second angle, so sine of 2 pi over 3, and then cosine will switch and use the first angle, pi over 4. So now it's just a matter of unit circle values. So we put our unit circles, so we know sine of pi over 2 is root 2 over 2. We know cosine of 2 pi over 3 is negative 1/2. Plus, we know sine of 2 pi over 3 is what, root 3 over 2, and we know cosine of pi over 4 is root 2 over 2. Now these unit circle values you should have memorized. I'm not going over how to find them because we've been doing this for months, right? We should have them memorized. So I do my arithmetic. Over here I get negative root 2 over 4 plus, over here I get root 6 over 4. So that ends up, they already have a common denominator, thankfully. And so I get root 6 minus root 2 over 4. Root 6 and root 2 and root 3 kind of show up a lot of times in these. And that makes sense because those are the unit circle values, right? So you'll see those values over and over again. So that's how we would do addition and subtraction in this circumstance. Okay, are we okay with that? All right, let's go to the next type that we will see. No, I'm not a fan of... Oh, so you need to know how to rationalize for multiple choice questions, but now you know, right? You've done it for years, so I'm fine if you don't. All right, so number 3 is a different kind of question that we'll be faced with for these addition and subtraction properties. So let's tackle this one. Sometimes students have trouble with this one, so stay with me here. In order to do these, you're going to have to draw triangles in the proper quadrants. Because if you don't, because these are not unit circle values, but we've done this before. It's been, a few weeks, but we've done this before. We have to know where the, the principal value for these are. So we know that for actually all the positive, we're in the first quadrant. So this one is going to be A, and it's going to be in the first quadrant. Tangent is opposite over adjacent, so that would be 2 over 3 right here. I do my Pythagorean, I get root 13. That is triangle A. Triangle B, we're just basically it's this angle measure, right? That would be angle measure A. Also is in the first quadrant, so this is B. This is angle measure B. So let's see, sine is opposite over hypotenuse. So we have 5, and then hypotenuse is root 41. I do Pythagorean and I get 4 there. Okay. So we are going to do the rules, the addition rules, but instead of pulling values from unit circle, we're going to pull values from the triangle. I mean, right, we've done this before. It's just an extension of what we've done in a previous unit. I think it was unit 2 maybe. I don't know. Maybe it was unit 1. I think it was unit 1 that we did this. All right, so here we go. So tangent plus. Tangent plus. So let's remember. So that would be, I'm just going to write the formula. A would be the first one in this case. B is the second. So in the numerator, if you will recall, we would have tangent A. And since this is adding, it's going to be plus tangent B. In the denominator, remember it's always a 1. And do you remember the sign? If the top is positive, it's going to be opposite, it's going to be minus, and it's going to be the product of those two. Tangent A, tangent B. All right, so now to get those values, we're going to have to read them off of the triangles. We need to be careful to read them off the proper triangle. In this case, since we're adding, it's not as big a deal. It's a bigger deal when we're subtracting. So let's see. So tangent on the triangle A. So is opposite over adjacent, so that's 2/3. Okay, not too bad. Plus, tangent on the second triangle would be, 5/4. All over, 1 minus. And again, we already found tangent of A. That was 2/3. And we already found tangent of B, that was 5/4. So that's plugging into our formula. Now it's just a matter of arithmetic. We're just going to use arithmetic and we will get to our answer. Just because we're on pep rally schedule, I'm not going to go through each step of the arithmetic. I hope we're okay with that. We know we'd have to find a common denominator and do all that jazz. What you should end up with once you do all of that would be 23/2. That's what you should have for your arithmetic. Okay? So that's another type that you will be faced with. So, everybody okay? Yes. Well, I took tangent of A, right? Tangent of A is opposite over adjacent, so I took the tangent of A and replaced it with the value of tangent of A. Okay? Any other questions? All right. So let's look at number 2. This one is a little bit counterintuitive, I guess. We're actually going to be going backwards. So notice that I've got sine and cosine mixed, and I have a plus. Which one of the trig functions, addition or subtraction identities? That's sine addition, right? So that's sine addition. So we know what it is. It's sine addition. So let's write that out. So we know it's sine. We know it's addition. So it's going to be 18 degrees plus 27 degrees. Right? We okay with that? So we're kind of going backwards. And we add 18 and 27, and we actually get, 45. So we just evaluate sine of 45 degrees. It's a unit circle. We know what that is. That's root 2 over 2, and that's our answer. Okay, we okay with that? Yes. So for these numbers right here, you're talking about? Right. So if you're subtracting, is it going to be the number that is a positive number? So no, it could turn out to be a negative angle. If it is a negative angle, we would have to use even odd properties to fix it before we evaluated it. Right? We don't want to keep the angle negative. So we would need to use even odd properties. All right. Last one. Oh, a proof. I know you were missing proof, so I added one in for us. So here, look how close that looks to cofunction. What's different? It's second. So see, we're going to have to pay attention. Now, we actually have options here. We really could factor out a -1 and do some even odd stuff with it and turn it into cofunction. We could. I'm not going to go that route because we just learned sine and cosine addition and subtraction properties. But again, like with all proofs, there's more than one way to do it. More than one way to do it. But I'm going to choose to use the technique that we just practiced, that we just learned. So I'm going to use the sine addition property, and we are in this case subtraction. We know sine is the nice one, so we've got sine of x, and then cosine of pi over 2. If sine is asked to subtract, what's sine going to do? Sine is going to subtract. And then we've got sine of pi over 2 and cosine of x. Notice, now this might have been what you were asking. Notice this subtraction sign right here. That decided which formula I was going to use. It did not make the pi over 2 negative. Okay, it just determined which formula I was using. I'm using the subtraction formula. But the pi over 2 is positive. Okay? All right, so that's equal to the right-hand side. Right-hand side, and the reason is subtraction property. Okay, so now we've got unit circle values that we can work with. So we've got sine. We know cosine of pi over 2 is 0. We know sine of pi over 2 is 1. And this is trig values. Okay, that's my reason, would be trig values. Now I'm going to, we know 0 times sine is 0, so this leaves me negative cosine. And this is just, multiplication. And there's our proof. Okay? So that's just an example of a proof using an addition or subtraction property, because you will see them. All right, is everybody okay? Okay.